Hey folks, we are going to do an example with parallel circuits. If you already have this circuit copied from the previous video, you can just use that. However, if you don't already have that circuit copied, you can recopy it now. Here's the circuit we're going to be using. I also rewrote Ohm's law here. And as a reminder, I'm going to write how to find the total resistance for a parallel circuit right here. Okay. All right, so if you need to pause the video, now would be the time. If you want to draw this pretty big, because we're going to be drawing all over it. Okay, so what we're going to calculate is we're going to calculate the total resistance, the total equivalent resistance of your circuit, and we're going to calculate the currents and voltages everywhere. So first, we're going to use this equation. Now, there's a couple ways to do this. So there are fractions here, so I'm going to go ahead and sub in what we know. So the equivalent, 1 over the equivalent resistance will be 1 over 4 plus 1 over 12 plus 1 over 8. Okay. Now, if you have easy fractions, it might just be as easy to go ahead and get common denominators and add them up. So like the common denominator of 1/4, 1/12, and 1/8 would be a 1/24. So this would be 6 over 24 plus 2 over 24 plus 3 over 24, which adds to 11 over 24. That's 1 over REQ, so don't forget to flip. So 1 over REQ is 11 over 24. So REQ is 24 over 11. Make sure you flip that. If you divide that out in your calculator, you get 2.18, and the 1/8 are repeating, and this would be ohms. Notice that that overall resistance is less than any of the individual resistors we had in our circuit. Now, if you don't want to do the whole fraction thing, no problem. In your calculator, if you just take 1 divided by 4 plus 1 divided by 12 plus 1 divided by 8 and add that all up, you'll get, oh, and I got to do that in my calculator. Flip that over. You'll get oh wait, no, sorry, got to do it in the calculator. So 1 divided by 12 plus 1 divided by 4 plus 1 divided by 8, you get a decimal. You get 0.4583, and the 3 repeats. Oh, that's a little messy. Let me rewrite it. 0.4583, and the 3 repeats. Okay, and then you still do the same thing. That's 1 over REQ. So you have to remember to flip that. So in your calculator, REQ would be 1 divided by 0.4583 repeating. And if you do that, you're going to get your 2.18 with the 1/8 repeating. Okay, so that's your total resistance of your circuit. Okay. To find the total current leaving the power supply or the battery, you just do Ohm's law. I is V over R, which is 12 divided by 2.18 repeating. And if you do that, you're going to get 5.5 amps. Okay, so going back to our circuit, I'm going to draw that. This current here is 5.5 amps. Oh, let me make that a little neater for you guys. Okay, now notice I start my arrow right back by this junction, and I end my arrow right before this junction. Okay. Well, we know that the voltages for all 3 resistors are the same. They're all parallel with the battery. They're all 12 volts. So for each of those, we're just going to take 12 divided by R to get the current. So for R1 there, okay, so we'll call that I1. That's just 12 divided by 4, which is 3 amps. So I'll go ahead and list that up here. This is 3 amps. Okay. The current through R2, we'll call that I2, is just 12 divided by R2, which is 12. And hopefully we don't need a calculator for that. That's 1 amp. Okay. So this current here is 1 amp. And finally for R3, that current would be 12 divided by 8, which is 1.5 amps. So this current here would be 1.5 amps. Now, on a side note, this junction right here, 1 amp goes this way and 1.5 amps goes this way, so how much current has to be feeding that junction? Well, you got to have 1 plus 1.5, that's 2.5 amps, okay? Same thing down here. This current here has to be 2.5 amps because 1 amp plus 1.5 amps going into that junction has to equal 1 plus 1.5, which is 2.5 amps coming out of that junction. Finally, for this junction right here, notice that the current, you have 5.5 amps going into it right here, okay? Well, 3 go down and 2.5 go this way. Well, what's 3 plus 2.5? Hey, it's 5.5 amps. So that's how you calculate several things. The total resistance of your circuit, the total current leaving the power supply or battery, and the currents traveling through each individual resistor. Oh, and finally, the current any other place. You can just add up or subtract the currents in your junctions. I hope that was helpful, and thank you very much.